Okay, so here we have an angle and its corresponding side and one of the other sides. So this is an angle side-side postulate or triangle type. So we have to figure out is this triangle even possible? Is there more than one? All right, so let's check it out. Now, when you're setting these up, you have to pay attention. So this is saying that our triangle has a measure of 80 degrees here at alpha, and the side opposite alpha is 100. B has a side size 10 opposite it. We don't know what beta is. And we have the complete unknown pair for gamma and C. So let's start with beta. Sine of 80 degrees over 100 is the sine of our unknown beta over 10. Okay. So our common denominator here is actually 100. But I could just multiply by 10 and that would get sine B by itself. But I write it on one side, I write it on the other. That's the sine of 80 over 10 because 10 goes into 110 times. So this is now what we're going to apply the sine inverse to. And we're going to see what we get. I am sorry so much about the falling asleep, guys. I'm trying to stay awake and it is just struggle constantly. So sine of 80 closed divided by 10. And then close that. So this says beta is 5.65 5.651, sure. And we took an inverse trig function, so this is an angle measure. All right, but we did get a positive number, so that tells us that this right here is 5.651. All right, which they did say nearest 10th. So we'll actually go with 5.7. So 180 minus 85.7. It's 94.3. All right, so I have angle B, I have angle gamma. Now I can use that to find side C for this triangle. Then we're going to have to check to see if there's a second case, and I think so, because we got a measure for A. and it's smaller than B. Sorry, C. So the sine of 94.3 to C. And the sine of 80 over 100. All right, so I multiply both sides by 100C and then divide by this sine 80. I get 100 sine of 94.3 divided by the sine of 80. One hundred times sine of 94.3 divided by sine of 80 degrees. All right, so C measures 101.3 once we round it. All right, if we try to force, well, in this case, A is bigger than B. All right, one more. Determine the number of triangles possible. So we don't actually have to produce them. We just need to label things. Ah, they're trying to trick us though. Instead of giving us angle alpha, they gave us angle beta. All right, so let's draw our silly looking triangle. Beta is 48 degrees. The side opposite beta is B, which is 26. I guess we'll put alpha down there and gamma up here. And the side opposite alpha is 31. All right, so we have our known quantities are the angle measure, this fixed side, and this fixed side. So that 26 is smaller than 31. And our angle's not too tiny. So let's go ahead and set up with alpha. The sine of alpha goes with 31. And the sine of beta, 48 over 26. All right, let's solve for A. 31. Sorry, guys. I am just on the struggle bus today. All right, that is going to give us an angle measure. Solving through it, though, we don't need to work because the question was just how many triangles. So this is actually more a question of, we have the angle of 48, we have the 31, we have the 26. Is the 26 long enough to hit the ground? It kind of seems to be, but let's calculate that height. The right side would be the sine of 48 degrees times 31. And then we're going to take the inverse sine of 31 sine 48. Close that one, over 26, close that one. That gave us 62.4. God, I really am way too tired for this. I'm sorry, guys. I need to actually draw the triangle is the problem. So if this is 48 degrees, this is what we want. This is 31. Sine of 48 equals h over 31. So h is 31 sine 48. The h is 23.03 blah, blah, blah. So this is the minimum length that drop-down side has to be. It has to be at least 23.03, whatever units we're talking about. If it is more than that, then we get our weird drag two triangle situation, which answers this question. The 26 is not bigger than the 31, so we don't have the outside case where there's only one long stretch. So this is two triangles. All right, I think I got one more in this section.